Okay, this is 3.2 Quadratics, and this is part 2. We just finished talking about degrees, and I want to show something because of the symmetry. We have some interesting things that happen here with our graph. You can take a look, and certainly if we have more than one place where the graph touches, with a quadratic, we're going to have 2. And if you stop and think about it, here's our axis of symmetry, right? In this case, it happens to be the y-axis, but it doesn't have to be. But whatever our axis of symmetry is, we know that because this is symmetrical, once we find out the distance from the vertex or the axis of symmetry to the place that we have a root or we have a real solution, we know that it's going to be the same distance here to go to the left. So we have something that's both the plus and the minus distance from the axis of symmetry, right? Remember this gives us our axis of symmetry, or the x value for our vertex. So we have a couple of ways of approaching this, and I want to make certain we cover both, but I want to make sure that people are seeing and understanding what's happening and why we have that plus and minus feature going on. We're talking about from the axis of symmetry, both to the left and to the right on that. So our two options are completing or perfecting the square and the quadratic solution or the quadratic equation. Personally, I prefer to call it the quadratic solution because any equation that has an x squared in it as the highest degree would arguably be a quadratic equation. Okay, so for completing the square, all right, both of these will always get you to the right place, but it's a little challenging when you're thinking about it in one case versus the other. So first of all, if a in our equation is not 1, then we divide the expression by a. So we want a to be a 1 before we're done. Next up, we're going to move what I'm going to refer to as the old c to the other side of the equation. All right, so here's our original equation, and then I'm moving that 3 to the other side, right? That negative 3 becomes a positive as you move it over. So that's pretty crucial, okay? We're going to make room for what's coming next. All right, so we're going to divide b by 2. All right, when I say b, I'm talking about this value here, which is the same as this value here, which is why I have it highlighted in yellow. We're going to then square the result. And I got to tell you, this is the really cool magic part. This is where the whole purpose of doing this is just like, all of a sudden it suddenly will make sense at some point, and it's just like, it's the coolest thing ever. So, you're doing this kind of off to the side, and here, again, you've got this, the 2 is in here, and you've got to divide by the 2 because you have the 2ab. If you're using that particular cheat, right? So as we go down here, we're going to add the new c, right? Here's our old c. We're going to add our new c to both sides. So in this case, I have x squared plus 2x plus 1 is going to equal 3 plus 1, right? Now, again, this process gives us a really cool way of addressing this. Whenever we have something in this particular format, which is what we did, that's why we perfected the square, right? If you take a look, this is going to be exactly the same as what we expect. So in this case, it can break down to a plus b quantities squared. All right? So when I had this, right, is the same as this, and it's like, oh, well, I can just take this and call it this. And you're going to see why that's important, but it's really crucial to realize this is the big trick. This is the big magical moment, for lack of a better word, that we understand what's happening. Okay, so we're going to have our x plus 1 quantity squared is going to equal 4. Well, I want x alone. I don't want x plus 1 quantity squared. So first thing I'm going to do is I'm going to take my square root on both sides, right? So I take my square root. That leaves me with an x plus 1 on one side, and then the square root of 4 is going to be plus or minus 2. All right? Now, we're going to finally isolate the x. We're going to move that plus 1 to the other side. So now I have x equals negative 1 plus or minus 3. All right? So now I'm saying I have, here's my y value, I should say. That's my y. And then somewhere here, right, here's my vertex, my min, right? And that's going to be at negative 1. And when I go from negative 1, which is my axis of symmetry, right, my negative 1 minus 2, right, is going to give me a negative 3. So one of my solutions is going to be negative 3, 0, right, this one here. And then I can go with x equals negative 1 plus 2, which is the plus half of this. That's going to give me a positive 1. So graphically, my positive 1 is here, and my coordinate point is 1, 0. All right? So here's another example. And I'm going to just kind of zip through it. You're welcome to go back, pause this, and take a look at whatever you need to do. All right, so here's my original equation. I'm given this piece of information. And then I am given, I'm going to do this using completing this square, which means I've got to move that old c to the other side. I'm going to take my b, and I'm going to take that b and divide it by 2, which is going to give me a negative 5. And then my negative 5, I'm going to square, which gives me 25. All right? And so this goes both places. This goes here and here, right? All right, so I've set it equal by putting it in both places. No big deal there. Now I'm going to go ahead and break this from my perfected square, right? I'm going to break this back down to this. All right? And remember, that was the whole point of doing this, is so that I can go from this value down to this. That's like the really cool part of this. And I want to point out that this negative 5 is the same as this negative 5, right? This is what's going to factor out. This is what it's going to factor to, right? I'm going to have this x minus 5 because of that minus 5 there. At this point, I want to take my square root on both sides. All right, I take my square root here, so then I'm left with x minus 5 on this side. Now I have the square root of 12, okay? And if I take a look at the square root of 12, if I break it down to primes, here is square root of 2 times the square root of 2, which is the square root of 2 quantity squared. So these two are going to undo each other, and that's going to leave me with a plus or minus 2, right? And then I have my square root of 3. I can't do anything with it except bring it along. All right? So, in this case, I am going to go ahead and I'm actually going to work this last one through with the video. I'm going to start it again in just a moment, and I'll pick up this example at that time.